Welcome to our 11th recorded lecture for Computer Programming 1. Right now we're going to talk about strings, which can be a bit confusing in Java, and information on this lecture will be covered in quizzes 5 and 6. So information from here, write down and put it down for quiz question suggestions for number 5 and 6. Now, I'm back in the US right now in my home just outside of Cincinnati, and probably you're watching this in a similar location, somewhere in Ohio. Now, as you know, every 4 years, Ohio is an extremely important state. And everybody wants to talk about Ohio once every 4 years. And then for the other 3 years, it's just plain old Ohio. And why is that? Well, the reason is Ohio is a swing state. And so this happens to be one of those 4 years where Ohio becomes incredibly important and we see a lot of high-profile people, and then after November they all disappear. So what I want to do here is explore strings and substrings in Java. And let's see, I'm going to bring up our math examples from earlier. I might just go ahead and add this to our existing math examples. What I want to do is say string state equals Ohio is a swing state. Okay? And then I'm going to say state.substring 11, 14, and I want you to think about what that's going to return. Of course, that's an unfair question because I haven't told you anything about substring. So let's talk a little bit about strings, and then we'll come back and answer this question. What will state.substring 11, 14 return? First of all, what is a string? Well, if we go to ucjava.com and then click on the link for Computer Programming 1, go to Variables and Types, and you're going to see under that a slide called Strings, and then we can click on Strings. We're going to explore each of these slides in this lesson, strings, substrings, so on and so forth. The demonstration and lab, I'll do something slightly different, but the lab you're welcome to look at on your own if you wish, if you want some more practice, which I would recommend, and I have 2 different answers for it. You can do it one of 2 different ways. But this is a nice way, not graded assignment or anything like that, where you can get some hands-on practice outside of our lecture. So what is a string? That's actually a fairly difficult question to answer because we know in Java we have 2 basic categories of data types. We have primitives and we have classes from which we can make objects. We know there are 8 primitive types. The whole numbers are byte, short, int, and long. The floating point or decimal types are double and float. And then we have the 2 kind of different ones, which are char, C-H-A-R, which represents a character, and a boolean, which represents true or false. Those are all 8 primitive types. We also know that if we're creating an object from a class being the other big category, that if we're using an object from a class, we have to invoke a constructor first. We explored this in our last lecture. So right here, I'm declaring a variable named myVehicle of type vehicle. Vehicle is a class that we defined. I must assign to this a new object of type vehicle, and I get this object by invoking the new operator and then the name of the constructor that I wish to call. This is how we make an object from a class. But what's this then? It kind of looks like a primitive, but not really. Strings aren't primitives. They can't be. There are only 8 of them. On the other hand, we don't have a new operator coming here. We're not calling a constructor. At least it doesn't look that way. So strings are kind of hybrid. Strings are definitely a class, and we definitely make objects out of them. But because they're so frequent, we could do this. Whoops, almost, sorry. Let me fix my paren. We could do this, but because, see, we're calling a constructor here. But because strings are so frequently used, the Java Development Kit and Virtual Machine let us take a little shortcut. And we can define a string literal, in other words, literally a string, by putting a string in quotes. And then we can make that part of an assignment statement. So here, on the right, we're declaring a string literal, and we're storing that into the variable name state. And that's a variable of type string. So I'm going to say declare and store a string value into the variable name state. And that's fine. We just have to remember, strings are not primitives. And there's just a little shortcut here where we can make a string in memory without us calling a constructor. In the background, the Java virtual machine will call a constructor, but it lets us do this little syntactic shortcut to prevent us from having to do all that work. Now, once we have this stored in a variable of type string, we can invoke methods on it, and we can only invoke methods on objects. We cannot invoke methods on primitives, not directly at least. So we know that this is an object. Okay, an object of type string. So substrings get a little bit tricky. Substrings are parts of strings, but if we have something like state.substring 11,14, we have to be very careful and explore what each of these numbers mean. This is an area where Java and the Microsoft languages like C# differ. So a fair warning, if you've done C# programming before, this is a little bit different. In the Microsoft and languages like C#, what this will mean is I want part of the string called state. I want to start at character number 11, and I want to get the next 14 characters. That's what it means in the world of Microsoft. And I have to be honest with you, that makes more sense to me than the way Java does it. The way Java does it is I want to get a part of the string stored in the variable name state. I want to start at position 11, and I want to end at position 14. Now, that sounds simple enough. I just want what comes between 11 and 14. But what gets tricky is, believe it or not, how do we define 11? How do we define 14? In other words, how do we define the begin index, and how do we define the end index? The rule is, if I can put it into words, the rule is this. I'll tell you the rule in about 2 sentences, but actually understanding it takes a lot more time. The rule is we will get the substring with the begin index, that first number, inclusive, and the end index exclusive, and we start counting a string with the number 0. So that's the rule, but what in the world does that mean? Let's go back to my spreadsheet now, and we'll take a look at Ohio as a swing state. Remember, what I said is we start counting letters at position 0. We don't include the quotes. The double quotes, that just means, hey, this is a string literal. So let me do some math here. I'm going to put 0 for the O in Ohio, and then we'll just make it, we'll just use a little Excel formula and say previous number plus 1. And then I can take that and I can drag that over here. No, okay. Now what in the world? Why'd you stop? Oh, okay, there we go. It's just slow. Okay. Okay, so here we go. I have now numbered each of these letters 0 through 20. Remember, we start counting at 0, and that's what gets confusing part 1. Most people think we start counting at 1. But no, for strings, for characters, we start counting with position 0. Now, I said if we get a substring, we're going to get the begin index inclusive. That means we start at and we include the letter at the begin index, which in this case is 11, because remember I said 11, 14. Okay, 11 is our begin index, 14 is our end index. So we start with the begin index inclusive, and we end with the end index exclusive. In other words, whoops, sorry, I went to the wrong, don't do that. Sorry, let me Control Z that. In other words, we include the 11, we do not include the end index. We stop right before the 14. Okay, we include the character at the begin index, all the way up to, but not including, the character at the end index. And that gets tricky. So Ohio is a swing state. 11, 14 returns when? Now, a side note, I'll go ahead and run this and we'll see that I'm not lying to you. A side note, I've given this lecture and given this example many, many times in class, and I always start and I draw this up on the dry erase board. Ohio is a swing state, state.substring 11, 14, and I ask the class quickly for an answer in exchange for a free quiz grade. And of course, without explaining it, most people don't know what the proper answer is, which is understandable. One time, a student in class immediately shouted out the correct answer, and I honestly was blown away. It ended up he had taken me in a previous class where I did this exact same example. And he went into work the next day, gave the same quiz to his coworkers, and showed them how this worked. Then he went to erase his dry erase board and realized he wrote it in permanent marker. And for the next 3 months, every time he sat down, he stared at Ohio is a swing state, state.substring 11, 14 equals when. Nonetheless, here we go. Let me go ahead and I'm going to right click and choose run file. And what we'll see, of course, well, you know what? I didn't print it out, did I? Okay, sorry. Looks like I have some more work to do. What I'll say is string substate equals, there we go. What I'm doing is I'm taking the result of this equation, assigning it to a new variable called substate, and then I'm going to do a system out print line and say, substate value, or what the heck? Let me just print the whole thing out as a label. 1 second here. Ohio is a swing state, 11, 14, and then I'll say substate. Okay, and we'll save. And now let me run. Okay, I'll right click and choose run. And sure enough, let me scooch over NetBeans a bit here. Ohio is a swing state, 11, 14. The answer is when. Okay, so once again, we start counting characters at position 0. Then our substring is begin index, end index. We include the begin index. We do not include the end index. We go up to that point and then stop. And that's what gives us the word when. Very confusing. The moral of the story here is, if you're ever doing substrings, always test thoroughly. One of the first jobs that I had, and this is going back to 1997 when predominantly corporate computing was done on a mainframe. One of the first jobs I had was to take a mainframe file with monetary values and put it into kind of like a program that would run on your PC, a client-server program. I did a substring and everything looked good to me. I didn't realize I was using the wrong index, and I ended up chopping off one number from these dollar amounts. And so $1,000 was $100. And in the mainframe world, there wasn't like a decimal point. What you would do is you would declare, say, 10 characters for a dollar amount, and then just say the last two were decimals. So there wasn't like a decimal point. You just had to know where that decimal started just by where it was in memory. And so I did a substring, miscounted, and I ended up chopping off one digit. It almost went live, and luckily one of my coworkers caught it. So be careful. Test very thoroughly. Test your stuff very thoroughly so that you don't cause problems with that. So there we go. Part number 2. I'm going to print out the original, okay, state. I'm going to print out the original string, okay, and I'm going to save, and I will run this again. What we see here is that the original variable remains unchanged. When I say substring, I'm not changing that original variable state. I'm simply returning a new string that's equal to that expression. That's because in Java, for memory reasons, strings are immutable. Once made, they cannot be changed. Now, we can reassign that variable state. We can certainly do that. But there's not an operation you can do on a string that will actually change that string. Typically, what you can do is run a method on a string, and that method will return to you a brand new string where the value is whatever that method does. So here, substring on state did not change what was in state, because we see we still get Ohio as a swing state when this line prints out. It did not change that. Instead, it grabbed the word when, returned that, we stored that variable in substate, and then we print it out up above. So in Java, strings are immutable. Once created, they can't be changed. Okay? Again, you can reassign the variable, that's fine. But you can't do any operation on this variable that will alter this original string. All you can do is reassign the variable. That just helps for memory and performance. Okay, so some of the other methods we're going to look at, if I go back to the slides for this class, we're going to see string methods. There are several here. We have length, will tell us how many characters in a string. We see the substring method. To uppercase, again, will not change a string. It will just return a new string. And that new string will be the value of the original string, but all uppercased. To lowercase, same thing, but lowercase is it. Replace is a nice one. If you want to go through a string and replace a certain character, you can use replace and pass in the new character and the old character that you want to replace. So the new character will replace the old character within the string. I use that one occasionally. That one can be kind of nice. As a matter of fact, the new character can just be nothing. It can be an empty string. I'll do that if I need to clean up a string and take out some unwanted characters. I've done that before. So we'll take a look at some of these methods. Okay, comparing strings, we'll hold that for when we get to if tests. So that'll start us for now. Okay, let's relate this to our original example about vehicles. You might remember in prompt user of our driver class, we created an object, a vehicle, and then we populated it based on user input. Okay, this one we just hard-coded, but we populated it based on user input. Now, it might be a bit frustrating to you that we have two different classes here that have to work together. And that's understandable, but there's good reason. To be honest with you, a lot of introductory programming courses throw everything into one class because it's easier. And then later on down the road, they split them out into different classes. The problem is that showing you how to do it the wrong way first by putting everything in one class, and that starts bad habits. I've tried that before. I do not like the results because it just ends up being confusing. The way we're doing it is a little harder up front, but it's going to make life much easier down the road. It's going to start us off with some good habits. So we have a user interface class called driver, and we have a data class called vehicle. So driver has all of our prompts to the user and all of our output. Vehicle stores our data and has our calculations. And the reason why we do this is many times we want to use different user interfaces but maintain the same logic. Think of iPhone app, Android app, web page. And again, the one example I use quite a bit, a lot of times I'll book a flight on delta.com, and then at the airport, while in line, I'll use their mobile app on my Android. There was one time I was flying to England, literally in line on one flight, and it was getting delayed. Delayed so much I was going to miss my connection. I rebooked in line, ran to another gate, and immediately boarded another plane. Went through Detroit instead of Boston. Got to England on time. So we think about this, different user interfaces, same business logic, very important. We don't want to reinvent the wheel each time we have a different user interface. Now when I say user interface, the keyword there is user. Well, and the keyword's interface, honestly. They're both important. But we're just collecting data, right? What if this data is coming from another system? What if this data is coming from an external system? Definitely something very possible. And another example I have to use that's close to home for me is the Plant Places color search. So I can go to plantplaces.com, and let's say that I have a specific theme in my landscape. Maybe I'll tell you, if you're into plants, A really easy color to find in plants, white, pink, yellow, no problem. Very difficult color, think about this one. Think of a blue flower. Think of something that flowers in a perfect blue. Very, very rare, very rare. So let's say that I want maybe a yellow plant. And think about fall colors too. Hit search, and what we'll see here, that first one was a test, ignore AB Silicica. Everything we see here comes in yellow. Take a look. Everything here, all the plants we see, match that yellow color that I started with. Okay, let's say I want to go with something, a very bold looking pink. Take a look. Every plant that came back on this search result has some kind of shade of that fuchsia pink at some point in its life cycle. Now this is great if you're on the web. I'll tell you what would be really neat, and this is one thing I've gotten to work for myself and still kind of testing it out, but what if you could just be out in the landscape, take a picture of your house, and then touch that picture and say, I want this color. Works the very same way. It's just a different user interface. It's a different way. So in that case, my Android phone is going to call plantplaces.com, give it some color values. Plantplaces.com is going to return some results. Now, it's going to return these results as data to the Android app. The Android app is going to take that raw data and then present it to the user. So in that case, we're just switching around data. In this case, if we're doing it online, then actually the Plant Places web application that we're looking at online, that's what's making the user interface as well. So many times we'll see this need to do different kinds of user interaction with the same logic in the back. And it's very important to reuse that same logic because it reduces redundancy, it saves us effort, so on and so forth. Now, we know that this is what the Plant Places app looks like live. If I go back and search for, let's see, the colors I searched for there were red 225, green 80, blue 181. That's what the Android app is going to send to Plant Places. So 225, 80, 181. I'll go ahead and I'm going to act like I am the Android app now. 225, 80, 181, and then an accuracy of 10%, which means give me a color within 10% of this red, green, blue value. I hit enter, and let's see, Nicotania, alata, and hibiscus. Let's go back and look at the results that we got. Hibiscus and Catharanthius. Well, it looks like it gave us, okay, close. Maybe I have a number off. I won't worry too much about it. Oh, you know what? Okay, I know what that is. Okay, in any case, this is what plantplaces.com is going to return to the Android application. In a browser, if I hold down Control and press U, it will show me the source of that page. So essentially, what plantplaces.com is returning to Android is a bunch of strings separated by semicolons, or as we call it, semicolon delimited. The job of the Android app is then to take that information and make it look pleasing on a phone. It's probably not going to look a lot like this web page, just because this is a lot of information to throw at a phone. When we're dealing with the phone, we're dealing with a very limited display, and therefore we need to make optimal use of each pixel on that display. So maybe it'll have a different user interface. Now, what does this have to do with our vehicles example? Okay, again, take a look at the data that the Android device is getting. What if, instead of prompting the user, what if we made data available to our vehicle's application in a text file like that? What I'm going to do in NetBeans is I'm going from the Projects tab to the Files tab. Okay? On Vehicles, I'm going to right-click and say New and then Other. And I'm going to make a text file. On this prompt, I choose Other again. And it's kind of hard to make a text file. It's not used to that. I choose Empty File, which just means any kind of file. Next. And now I'm going to call this cardata.txt and finish. Okay, now I'm going to come over here and I'm just going to push in some data. Let's see. We could make this data anything we want right now. Let's say the first character is what type of car it is. Maybe we won't use that yet. Then we have a comma. Then in the next position, we have the odometer reading, and then a comma. And let's say in this position, we have miles per gallon. Let's make it something like 20, and then a comma. And then in the next position, we'll have gallons of gas. Let's say 12.0, like so. So our job now is to make a class that's going to read in this data. I'll go ahead and choose save, and make a vehicle out of it, and then run that vehicle if we want. We don't have to, but if we want. So what I'm going to do, because this is a different interface, this is coming from somewhere else, I'm going to make a new class in my project. I go back to the Projects tab, the Vehicles package, right-click, choose New, Java Class. This is going to be run a totally different way from, if I were to run driver, so we'll say that this has a different way to start. Class name, I'll say Vehicle DAO. Why DAO? In programming, a DAO often means a data access object. It means we have a way of accessing data, maybe from a file system, maybe from a web service, which is a service that makes data available over the web. Most frequently, a DAO indicates we're hitting a database, but we don't have to. In this case, we're hitting a flat file, so we're going to call it Vehicle DAO, and that is, again, a data access object that is going to create vehicles. And I choose Finish. Just a different kind of user interface. Now, it's always important to not forget to comment, so I'll say Vehicle DAO creates vehicle objects by accessing a text file, a delimited file. Probably we'll want to put a copyright up there as well. No biggie. Okay, so, we'll say that this might be run as a scheduled job, something that's going to run on a timer. Needless to say, we want this to be able to start up totally independently of the driver class. So if we want a class to be startable, we have to give it a main method. So I'm going to say psvm tab, which will give me my public static void main. In a DAO, we'll typically have methods like update, delete, insert, and then something like select or fetch. That's typically the naming convention that we'll use. So I'm going to make a method. Let's say public, static, fetch, vehicle. Okay, open and close paren. I could make that private. Oh, I need to give it a return type. Well, what the heck? Public static vehicle, fetch vehicle. There we go. Okay, now it's a bit mad at me because I've given it a return type, but I'm not returning anything. So I have to do a quick fix to take care of that. Vehicle, my vehicle equals new vehicle. Okay, terminate with a semicolon. Return my vehicle. Even though this doesn't make sense just yet because we haven't read anything, remember the golden rule. We want to take care of our red lines as soon as we get them. We also want to take care of commenting, so I'll put some notes here. Let's see. Create an object that will be returned. Okay. Now up on fetch vehicle, I'm going to do the slash on the question mark, 2 asterisks, and then hit enter. And that will give me the Javadoc syntax for talking about this fetch vehicle method. And I'll say fetch a vehicle from a flat file. At this point, we have 2 valid methods, one called main and the other called fetch vehicle. Fetch vehicle is never called though, so it's not of much use to us. So in the main method, I'll just say fetch vehicle. Okay, and there we go. So we'll go ahead and assign vehicle, new vehicle equals fetch vehicle. So we're invoking fetch vehicle, Oh, did I misspell it? Vehicle, yes, vehicle. We're invoking fetch vehicle, okay? And then we're storing the result in a variable of type vehicle. Invoke fetch vehicle. This method returns a new vehicle object, and we will store that vehicle object in a variable named new vehicle of type vehicle. Close enough. There we go. And save. Okay. Now, we need to access the file on the file system, so I'm going to introduce two new classes. One's called File, the other's called Scanner. You're not going to need these in any of your programming assignments, but just so you know what they are, the object called Vehicle, or the class called Vehicle, will allow us to reference a file on, sorry, let me rewind that. I could actually rewind it, but I'll just fix it myself. The class called File will give us access to a file on the file system. And then the class called Scanner will let us read data from that file. So, access a file on the file system. File, let's see, car data equals new file. Now, notice what we have here. A few things. First of all, we have, maybe I should call that car file. Maybe that would be better. Car file, that's better. First of all, let's look at line 31. On the left side, we're declaring a variable named car file of type file. On the right side, we're invoking the constructor of class file. Just like in driver when we created a new vehicle, or just like up here. Same thing's going on here. So, two things though. Number one, it doesn't know what file is. It doesn't know what that is. That's a Java Foundation class, or in other words, a library class that we can use. Comes for free with Java. We just have to tell it we want to use it. So I click on the light bulb, and I say add import. We're just telling it where to go find this class called file. I click on the light bulb. I select the very first option, add import. Boom. And there we go. Makes things a little bit better. Now on the right side, cannot find symbol constructor file. You might remember we were talking about default constructors. The class called file does not have a default constructor. You have to pass in a parameter. Now I could go look up on the Java doc and see what parameter we want to pass in. I happen to know this one because I've used it a lot. I put in quotes cardata.txt, and what is that? What is cardata.txt? If I go back to files in NetBeans, remember, that's the file that contains our data. Now what's going to happen, it's kind of a shortcut here, but since I haven't given it a file path, it's going to look at what we call the root of the project. And the root of the project, if I go back here into files, is this. It's sitting right off the vehicles project. That's where it's going to start looking. Okay? This is one place where we have to be very careful to maintain our platform independence. If I did something like this, c:\\\, data \\\, cardata.txt, this might work well on Windows, but it's not going to work on Unix. So we have to be careful here. I see this happen in Java sometimes, and the minute you do this, your program will no longer work on Unix. What we have to do, typically we won't start with something like the C drive. What we would typically do though is use this thing called file.separator, and then use string concatenation, file separator plus data plus file.separator, and then the string concatenation operator again, and then car data in quotes. What this will do is it will put the file or the directory separator in at runtime for whatever platform it's running on. If it's Windows, it'll put in the / above the enter key. If it's Unix or Linux, it'll use the slash that is on the question mark. So if you are accessing a file, don't hard code in a path starting with C:\\. Always better to go from root and use this generic file separator. Okay? And again, this is a difference with Microsoft languages. With languages like C#, it knows you're going to be running on Windows. So you can hard code C:\\, if you want in C#. In Java, we don't tend to do that. We tend to use this file separator, which will dynamically pick the correct file separator. Okay, in our case, I just put the text file at the root of the project, which isn't a good design idea, but it does let me shortcut and do this. It does let me shortcut and do cardata.txt. So there we go. This just gives me a reference to the file. To read the file, I need to use a scanner. Use a scanner to read the file. Scanner has a lot of handy methods on it that we can use. One of them is next line, and next line will just read the next line from a file. I will say this is something that's changed a lot over my career. When I started out of college, worked at Procter & Gamble in '97, most of what we were doing was very much mainframe based. And mainframe programs tend to run at a scheduled time, and they tend to read from a file, do computations, write from a file. Then the next night, the next mainframe job runs, read from file, transform data, write to file. Sounds very rudimentary, but in the day, that's how things worked. And many times, if you did something like you wanted to update your dependents in HR or change your insurance, it would be a matter of days before that was actually reflected. Even today, I know on Blackboard sometimes some changes that go into the course scheduling, it happens overnight. Like if my class gets assigned improperly, which happens a lot, it gets assigned to Brandon Jones, who works in CCM, not Brandan Jones, who works in CECH. Many times I'll request the change and they'll say, okay, it'll be ready overnight. I don't know who's doing it. I get the feeling it's not Blackboard, but Universys or one of the systems that reads Blackboard. But that used to be very common. Now, many years later, we're used to real-time data. You know, you move money in your bank and you see it right away. And again, that in banking it was very big. If you transferred money between accounts 15 years ago, it'd take a day to show up. Now you can transfer money from money market to savings and then pay your credit card all immediately and get immediate confirmation of it. So in any case, in the mainframe days, it was very common that our user interface was a text file like this. So these days, more often than not, we're working with dynamic real-time data. Of course, the problem is, if you have real-time data and something goes wrong, you have to figure it out quickly. But honestly, that's not bad, because in the old days, since mainframe jobs did tend to run overnight, if something went wrong, you'd get paged and woken up overnight, which is something that happened to me many times, and I do not miss at all. Okay, now what I'm going to do is I'm going to say scanner I'm sorry. I'm going to say, yeah, we got it. I'm just going to switch it a bit. Scanner, my scanner equals new scanner. And I need to pass into this a reference to the file, car file. So I simply pass the file object into scanner. Now I know scanner exists, and it came out around Java 1.4.2 or 1.5. Very nice feature. But once again, this doesn't know which scanner I want to use. So I just have to click on the light bulb and say, I want to use Java util scanner. Okay? Now, one thing happens here that's a little bit tricky. It wants us to deal with what's called an exception. We won't learn about exception handling until either later in this course or more than likely in computer programming 2. So I have to do something here that I can't explain yet, but we will get to it later. Basically, what exceptions are is it forces you to decide what to do if something goes wrong. What if I gave it a dummy file, a file that doesn't exist? What do I do in that case? It's a good way to practice defensive programming so that we have programs that can respond successfully if they come across an error condition. So I click on the light bulb. In this case, I'll say surround. Let's go ahead. Oh, block is going to do. Statement, that's fine. We'll keep it at this. Again, ignore the try catch for now. We'll come back and talk about that later. Okay, that does create a new block because we see we have an open curly, closed curly. Again, it's just a way to say, what do I do if I can't find the file? Okay, after that, what I'm going to do is I'm going to say string car. That's okay. We'll say entire line equals my scanner dot next line. Okay, and I'll simply say this will read text from the file. Okay, and I choose save. Now what I'm going to do is I'm going to set a breakpoint here. We're getting past the 40-minute mark, and I know I have still probably at least another half hour worth of talking to do. So what I'm going to do is I'm going to run this in the debugger. We'll watch what happens, and then, oh, you know what? I probably could go ahead and finish this up. It's going to be, it might be a little bit long one, but yeah, I'll go ahead and finish this up. Forget it. Sorry, this one might go a little over an hour, but I'll do my best. That's okay. We'll go ahead. I'll set the breakpoint, and I'm going to run this in the debugger, and this is a case where we're going to want to look very closely at the variables tab in the debugger and see the value of our variables. So I right click and choose debug file, and remember what's going to happen then. It's going to run until it sees the breakpoint, the Pepto-Bismol line, and it's going to turn it green. When it turns it green, I can step through the debugger at my own pace, and I can watch the value of variables. Let's just make sure I have everything set up correctly. So I choose F8. Okay. First of all, it's creating our vehicle object. We won't worry too much about that. F8. Okay, we're getting access to our file. F8, we're giving the file to a scanner. F8, we're reading the entire line, and you know, I might have a little boo-boo here. I might not be able to see this because it might go immediately out of scope. 1 second. Ah, shoot, it did. Okay, let me try that again. The problem is when I chose F8 on 43, it jumped right down to this line here, and the variable entire line went out of scope. Because a variable is declared, a variable is alive from the point at which it is declared until the close curly of the block where it's declared. Since I didn't have any lines between these two, there was no place for me to stop and actually look at the value of entire line. So what I'll do is I'll just put in some kind of dummy expression here, like int foo equals 1. That will at least give me a place where I can stop and inspect that entire line. So let me do this again. Right click, I saved by the way. Right click and debug file. Okay, mint green line, I choose F8, it's going to construct my vehicle object, and we're back. Okay, get access to the file, get access to the scanner, read in the first line. Now see, now I have a stop point there where I can stop and look. Look at variables. Take a look at the value of entire line. The value of entire line. C, comma, 12,000, comma, 20, comma, 12. And that matches exactly what I have in cardata.txt. So we're good. Okay? Okay. And yeah, I'll tell you, I am going to go ahead and stop this presentation now. I get nervous when it goes too long in case something goes wrong and the file gets corrupt. I lose a lot of work. So we're just about at the 45-minute mark. I'm going to go ahead and stop this presentation now, save it, upload it, come back, and we will take a look at how we can take this car data, and this is what I want you to think about between now and our next lecture. How do we take this entire line, split it based on the commas, and then take each of these pieces of data and create a vehicle with attributes assigned to these values to it. That didn't make any sense. Let me say that again. How do we take this line, split it based on the commas, and then take each of these values and assign them to attributes of a vehicle object? That made a little more sense. So, okay, I'm going to go ahead and wrap up this video, save and upload it, And in our next video, which will be a lot shorter hopefully, we will implement this and see what we can do with strings. Thank you.